Hello friends, welcome back to Rising Mathematics. In this video, we are going to prove this theorem based on the concept of delta derivative of a function in time scale. Statement of the theorem is, assume f is a function defined from time scale t to set of real number r and let t is a point in set t to the power k. Then we have the following. If point t is right dense point, then function f is differentiable at point t if and only if the limit s tends to t f of t minus f of s divided by t minus s exists as a finite number. In this case, we call the delta derivative of function f is equals to this limit. That is, delta derivative of function f is limit s tends to t f of t minus f of s divided by t minus s, which is some finite number. Before proving the given theorem, firstly we will recall the concept of delta derivative of function in time scale. For a function f from time scale t to set of real number r and a point t in set t to the power k, if f delta t is the number provided it exists such that for any epsilon positive, there is a neighborhood say u of point t which is the intersection of interval t minus delta comma t plus delta with time scale t for some delta positive, for which we have the condition modulus of f of sigma t minus f of s minus f delta t multiplied by sigma t minus s is less than or equal to epsilon times modulus of sigma t minus s. So this condition is true for every point s in neighborhood u of point t. Then we call the number f delta t as the delta or Hilger derivative of function f at point t. Now we will start our proof. Assume that point t is a right dense point. Let us consider epsilon is some arbitrary positive real number. Then function f is differentiable at point t if and only if there is a neighborhood say u of point t such that modulus of f of t minus f of s minus f delta t multiplied by t minus s is less than or equal to epsilon times modulus of t minus s for all points s in neighborhood u. Now here we can observe that since our point t is a right dense point, so sigma t will be equal to t. So this condition comes from this condition. So here we have just replace sigma t with t, since we know that as point t is right dense, so sigma t is equals to t. So here replacing sigma t with t, we will get this term. So this is true if and only if we have this modulus of f of t minus f of s divided by t minus s minus f delta t is less than or equal to epsilon. So we get this term by dividing this term with t minus s, or by multiplying 1 upon modulus of t minus s to this term. So we will get this term, or this condition is true for every s in u, as this condition is true for every s in u. So now here if we observe this, so modulus of f of t minus f of s divided by t minus s minus f delta t is less than or equal to epsilon for every point s in neighborhood u. Now since epsilon is arbitrarily chosen positive real number, so we can make it as small as we want. So from here we can conclude that limit s tends to t f of t minus f of s divided by t minus s is equals to f delta t. So we have proved that if a point t is right dense point, then function f is differentiable at point t if and only if this limit is some finite number and delta derivative of function f at point t is equals to limit s tends to t f of t minus f of s divided by t minus s, which is some finite number, and this completes our solution.